All right, welcome back. Let's go ahead and take another integral. Let's do the integral over a region 5y over 5x to the fifth plus 1 dA, and they give us the region D is xy with 0 less than x less than or equal to 1, 0 less than or equal to y less than or equal to x squared. Okay. Let's first draw this thing. So if we draw the region that we're integrating over, y equals x squared, that's easy enough. Okay, from 0 to 1, this region here. Okay, so we're going to set up the integral is going to be from 0 to 1. This is going to be an x. 0 to x squared, that's going to be the limits of y, of 5y over 5x to the fifth plus 1 dy dx. Remember, because these limits are termed in terms of x, that integral has to be in terms of y. Okay? Another way you could write this integral is you could write from 0 to 1. And then, if you want to think about it in the other terms, this y equals x squared is the same as x equals the square root of y. That's the left-hand margin. The right-hand margin is x equals 1. Now, this integral, I don't think we can evaluate. At least not easily. Okay, but this integral will be easy to evaluate. This one that we have over here. So let's go ahead and do that. 0 to 1. Now we're going to integrate here. We're going to integrate first in y. So we're going to get 5 over 5x to the fifth plus 1 times y squared over 2, with y going from 0 to x squared dx. Okay. Now, I'm going to pull out the 5/2. The integral from 0 to 1. Now here, the 5 and the 2 have been pulled out. We just have this y squared to deal with. But y squared has a limit of x squared. So that's going to leave us with x to the fourth over 5x to the fifth plus 1 dx. Okay. Now, to integrate that one's much easier to integrate. I can just let u equal 5x to the fifth plus 1 du is 25x to the fourth with a dx. Sorry about that. And we're going to have 5/2 times the integral. Now, when x equals 0, u equals 1. When x equals 1, u is going to equal 6. Okay, let's keep that x to the fourth here. U is the denominator, and dx is now du divided by 25x to the fourth. And of course, the x to the fourth cancels. That's the whole point that makes substitution work here. Okay? So, 5 divided by 2 and 25 in the denominator, that's going to actually come out to be, magically, 1/10. Natural log of u, let me write it down. 5 times over 2 over 25. Integral from 1 to 6. du over u. This is 1/10. This is natural log of u from 1 to 6. Natural log of 1 is, of course, 0, so we get natural log of 6 over 10. All right, let's do another one. Let's stick with it. We're doing so well. Let's take the integral from 0 to 1, 3y to 3, 13 e to the x squared dx dy. Okay? Now, I don't know about you. No, I do know about you. You can't integrate e to the x squared. Okay? There's no way, there's no indefinite integral there that you can find. But what we can do is we can do a change of variables, or change the limits, and get an integral that we can do. Okay, so our region, well, if x equals 3y, that's equivalent to saying y equals x over 3. So that's a line like so. Okay, let me try something. A line like so. Sure, that'll work. Okay. Now, the line, this gives me the line x equals 3. So that's a horizontal line. Okay, so this line up here is x equals 3y, and that line there is x equals 3. This point here then is 3, 1. This is the region we're integrating over. Okay? So, this is a bad integral. We don't like it. All because of this e to the x squared that we're being asked to integrate. We don't know how to deal with that. But what we can do is we can now rewrite this. The limits in x, if we make x the outside variable, are from 0 to 3. The limits in y, okay, the limits in y are going to be from 0 to x over 3. And then we're going to take 13 e to the x squared dy dx. Okay? I think I said it backwards earlier. The inside variables depend on the outside variables. So I think I said that backwards in the earlier discussion. But I did it right. I don't know why I said it backwards. Okay, so let's go ahead and attack this integral. At least get it started. So, we start this integral, we're going to get the integral from 0 to 3. Now, when we do this integral, we're going to get 13 e to the x squared times y, 0 to x over 3 dx. So that's going to be from 0 to 3, 13 e to the x squared times x over 3 dx, 13 thirds, integral from 0 to 3, x e to the x squared dx. And you should all know how to integrate that. If you don't, take u equals x squared, du equals 2x dx, and go forth. All right, I'll see you guys in the next video.